So, hello, thank you everybody. Thanks for joining here. My name is Rolf Bittner. I'm with the Qt company. I'm working from Germany actually, not in Berlin as this room is named, but from Nuremberg. I'm in business development, and it's my pleasure to introduce you to Roland Krause from our esteemed partner ICS. And he's going to present to you something about automotive media management in future IVI systems. So, Volker, please.
All right, thank you very much. I hope you can hear me there in the back. Well, when I came up here, my boss, he followed me along all the way up the elevator to make sure that I understood what I was talking about and gave me some hints. He wanted me to rewrite my presentation. Fortunately, what he wanted me to do, I already did in the presentation. And what he was up to was, I gave him an overview of what I was going to talk about today. And so I don't understand all the technical stuff. You just really, in the very beginning, have to tell me why you are doing what you're doing. What is the purpose of all of that stuff? Why is it so hard to make an IVI system in a car that people actually want to use? And what are the challenges coming forward when people are actually going to spend less time paying attention to what is on the road, but have more free time and more time to do other things? So, we all know predicting the future is really, really hard. But we know a couple of things about connecting systems together, because we do that in other circumstances all the time. What we actually find that connected cars are very quickly becoming reality. They are reality at this point. I recently came into a lease of a new Chevy Volt, and that thing is connected. From your phone, you can see the status of your battery charging. That is already there. From the comfort of your couch, you can see on your TV, theoretically, how far your car's electrical range is going to be. But how does this communication work? Currently, it's all over proprietary interfaces, all over over data lines that are telematics data lines. And how is this to become an extensible system, essentially? How will we actually communicate with homes, phones, and tablets? The infotainment stacks in our cars are the natural choice to become these communication nodes in our automotive system, because they have the most capable CPUs, they have the most capable connection modes in the car. I mean, you know that the car consists of hundreds and hundreds of different engine control units, microprocessor systems that are usually connected through the CAN bus, talking to each other, talking to important parts of the system. That's how your brake system works. That's how your anti-lock brake system works. That's how essentially everything in the car works. But bringing in external systems poses significant challenges to the architectural design of our platforms. The use cases that we have, I mentioned that, but there are additional use cases. Let's say you're playing music at home, and you have to leave the house to go to an appointment. You unlock the house, you enter your car, and there is a possibility, or there was a wish for a user that you could pick up your music where it was left off in the house. That would be a very nice feature to have. This is one of the scenarios of connected house. Or let's say you're on the way to an appointment, and before you leave the garage, your car can warn you that your wallet is actually somewhere on the kitchen counter or somewhere in the house. Well, that connects a car to a smart home, for example. There are emergency or safety-related features, like when someone drives a car and the car breaks down and you want to notify someone in the house. So all of these things require different kind of connection scenarios. That could be the other way around. In the house, an alarm system was disabled. While you are actually driving the car, you would like to see a message into your car. So all of these things essentially require us to think about how we can have an open system with open communication modes. They require intelligent collaboration. And intelligent collaboration means that you have different components of hardware and software that are working together. And as I said initially, the purpose of all of this is actually completely, entirely clear. everything has to work to enhance our everyday life, to make our life a little bit smoother. That's why we're doing it, and that's the whole purpose of it. So connecting the car itself, the car to the home, is essentially uncharted terrain because of the component car at this point being entirely, completely proprietary. Proprietary means closed. The systems are closed. It's unknown, or it is not. There are no open systems available to a developer to actually work with the car at this point. We do understand, however, the medium phone as an interface. We understand that fairly well. There are systems like Android Auto and CarPlay that allow us to write applications as if they were for a phone that are targeted at an automotive use case. However, the infotainment stacks in the cars are completely closed and proprietary, and in order to have full functionality, at some point they need to find a way to allow for direct communication and direct connections. So let's look at these components. The automotive components, as I said, hundreds of sensors and actuators. Sensor stack management is the most intelligent, that is, most CPU, memory capable, drive capable, communication capable system in the car. Many times nowadays it's internet connected by itself through a 3G, 4G stack. Those things are all available. On the other hand, the home is a very open system compared to that. We have a myriad of different communication protocols that are shaping out, Zigbee and Z-Wave, Insteon, Bluetooth, Bluetooth Lite, Bluetooth LE, and so on and so on. Most of the proprietary, or most of the home systems offerings integrated with themselves. That is, if you have a smart home, you have a smart garage door opener, you get an iPhone or an Android application with it that opens that thing. But then if you also have a smart sprinkler system for your lawn, you get another application. Those things don't integrate across providers at this point either. You also have to consider that compared to embedded development, iOS development, Android app development is dead easy. In the embedded space, you're dealing with an entire set of other requirements and components. Because you're unshielded, you're much closer to the actual hardware than you would be in a guarded environment, such as in an iOS or an Android circumstances. You also have difference in the life cycles of your applications. Cars are expected to be around for 10 years. My phone is 2 years old, and I'm thinking about replacing it. So that's a order of magnitude difference in the life cycle. Consumer acceptance plays a role. That is also because consumer acceptance is guided by marketing, balanced with costs, essentially. Consumer opinion is formed to a large extent by marketing, advertisement, as you can see. However, there is a certain amount of cost that comes into it. When a phone costs $1,000 or $1,500, then probably the market for that phone shrinks appropriately or proportionally with the cost of that phone, for example. So an important part of all of this are how we actually create an ecosystem, how we nurture an ecosystem. And we can only do this with the help of standards and protocols, right? So we have to understand the importance of supporting the development of open standards. Otherwise, as I said initially, we're going to end up with the problem that is called the basket of remote controls. And that is the problem known to all of you who have a variety of devices connected to your TVs, and not one of them talks to the other, and you end up with a whole bunch of different remote controls that no one has to operate or program or and so on and so on. So this is a real problem at this point in the whole world of IoT for home and for connected home stories. Automotive manufacturers sometimes work directly with cell network operators, with cell phone makers. Now that's another possibility that we need to take into account in the whole connected home, connected car story. There has been a whole bunch of people working on standards in the open. The remote vehicle interaction effort that's spearheaded by some friends at JLR is a good example for it. The folks at JLR have provided prototype code, open source code. This code was adopted by the Geneva Alliance, which is an alliance of car manufacturers that has as its goal to come up with a common infrastructure system. This is all based on open source technology, open source technology that can handle the authentication, the discovery, authorization, and the exchange of data between all these different services. And at this point, you have some sort of a remote vehicle interface adapters that you can have both in the vehicle and the smart home, and you can have protocol adapters that collect all the different protocols that a home and the devices in a home can speak and transfer that to or communicate with an RVI core to a system, to an operating system in a car, be it based on Linux or be it based on something else. So we've, in the past, worked on a prototype implementation of a stack of automotive hardware and middleware. What I'm going to show you and what I'm going to talk a little bit more in detail about is how we attacked one of the many problems that you have, which is the media stack. So everybody who spends time in their car typically plays some music, plays some media, audiobooks, books on tape, uses their phone. So the scenario that we have today is people want to bring their own stuff. It's no longer, you turn on the radio, you got 3 stations, 1, 2, 3, that's it. Everybody has on their phone a myriad of applications, be it Spotify or Pandora or whatnot. Bring your own music, have your own music in iTunes that you want to play. So Bluetooth connectivity is one of those big ticket items that any IVI system has to have down today. At the same time as we are more distracted, rear seat entertainment becomes a feature that is requested and that is required. So what you should also have is the ability to remotely control an IVI stack. So how would you do that? Let's say the scenario is that someone sits in the back seat, has an iPad, and wants to play some music from their iPad and wants to also control what's being played. Or a second person that is also in the car wants to change the song that's being played for the iPad. How do you design an architecture that can provide all of these things? So the challenge for this is, to summarize, that people have to bring their own media. They bring their own media files to the car, and they want to share these media files. One of the subtopics that you have to address is the indexing of the media. How do you know what is on the systems? And this is what is typically called as indexing. And the indexing is also, it's preluded by recognizing that the device was brought into the car. So you need architectural components that can take care of these things, and they have to be flexible. So you want to have a multi-step requirement, you want to have a multi-step process for recognizing that the device was actually registered with the car, and this could be a USB stick that is plugged in. That's a very easy thing to do. This could be a Bluetooth phone that was connected. This could be an iPad that is physically connected via an iPad connection to the car. Or it could be a system that we have not encountered yet. It could be something that we have not yet seen that pops up in 2 years. And we don't know what the connection of it is, and we don't know really how to work with it at this point. So how do you plan for that? That's another interesting challenge. The idea is then to build a system that where we can actually use plugins such that we can code for the unknown. So, as I said before, we don't know what's going to be in 3 years. We have no idea what media people are going to be using, what interfaces people are going to be using in three or 4 years. right? Remember that there at one point was a Walkman. No one has that anymore. The CD has lasted us 10 years. Pandora is something that isn't even at this point very popular anymore because other things have superseded already. So how do we create all these things? One solution that's been proposed sometimes is just saying, let's give up. Let's just stick a mobile phone in the car. Let's just stick a mobile phone behind a touchscreen and be done with it. Or let's just put an Android tablet into the car. Let's just put an iPad there. This is, if you ask consumers what they want, a lot of times you will actually get that answer. Just put an iPad in there and I'm happy. You know, navigation works really well. I know how to use iTunes. I can blindly operate that thing. Graphics really good. So is that a good solution? Well, if you ask the car manufacturers, it is probably not. The OEMs do not want to give up the control of what they have in the middleware, in that stack there, and want to hand it all over. The OEMs don't actually want to become a very expensive, very fast mobile phone case. So our plugin architecture, our architecture relies on plugins. When our media manager's core functionality consists of loading plugins, the plugins that we've identified that help us at this point are a device manager. That's a plugin that recognizes devices. It follows an interface that you can write additional plugins to that find devices that we don't know anything about at this point. It consists of media devices themselves. Those are devices that currently store the media that we want to play. It consists of players. For certain sources, you need certain players. For a Bluetooth stream, you need a control player, an AVRCP control player. You need ATDP, which is the headphone protocol, to actually hear the sound. But if you want to control the actual media playing, you need an AVRCP player. That's just an example. You also need additional services. When you have media on your phone, you might want to have album art, you might want to have lyrics, you might want to have some background information, you might want to able to be searching and features. And then last but not least, you need controller plugins that control your media manager. And those should not just be the simple UI that you see on the touchscreen, those should allow for remote control. The media manager also needs to at some point be the instance that organizes the flow of the media information, the data from the device to the player, from the device to the controller, without making unnecessary copies of the data, because the media manager itself obviously does not need to copy any of the actual amount of media data itself. So you can see a little bit out of the diagrams here of how we organize this, what we think a media device could be. There are DLNA devices, Android phones, cloud devices, things that are connected via the Microsoft protocol MTP or over Bluetooth, and so on and so on. We have at our booth a demo of this where we just connected a USB drive, a pen drive to it, and we connected an iPad via Bluetooth and play media over this for our proof of concepts. Since we are here at a Qt conference, and we are often asked, well, how do you make plugins in Qt? That's actually pretty simple. This gives us a little bit of an idea of how it can be organized. You were working with a two-layer structure typically. We work with a device manager. We define a device manager interface, and it can be very simple and just emit a couple of signals, such as device created or device removed, with URL strings or URL types or whatever you want to do there. And then you register your plugin you declare your interface before you actually load your plugin and implement your plugin. So as I said, one of the important part of all of this architecture is the data flow. So how do you make sure that you don't get unnecessary copy? And what is the data that actually flows to the media manager? What it actually is the meta information. It is the location of where a file is that has to go from the device where the file is stored to the player that plays this. The actual data itself doesn't get copied. It has to be collected and grouped in order to become available for sorting and indexing and fast and finding. So imagine you have more than one USB stick, or imagine you have more than one Bluetooth phone connected to the system, and you want to play all classical music that comes from both of these phones. So you want to collect the information of the data that is on the phone first, then be able to filter it, search it, and play it appropriately. Other core components of the current Media Manager implementation is the notion of playlists. Playlists, source playlists as we call them, are associated with the devices, and the devices are abstracted in the form of sources, media sources. These are physical media such as phones and iPads and thumb drives. There could be cloud instances. On the other side, the actual player is interfaced to media sessions. Those are sessions that work on a specific part of a playlist, namely all the files that are of the same nature, such as all audio files, audio MP3 files, or such as all Bluetooth stream files. You can easily make JSON data structures out of the whole thing. That's a very flexible way to go about everything. You can see a draft for how media playlist entries can very easily be made. Qt's JSON support is excellent for this, as it makes it very easy to work with. And so this leads us to be able to take data from the sources, filter them into sessions, and then essentially have media players with very small and narrowly defined interfaces implemented that can then play the media. For example, a media player interface simply needs to only consist of a very few functions: play, pause, stop. It needs a couple more, but it's really just less than two handful, less than a dozen interface functions that you really have to implement in order to make a good player. So the core functionality of a media manager at this point consists in that you connect the device, a USB pen drive, and that you can then essentially play your information. The Media Manager gets the notification from the Device Manager plugin, creates a source object, stores the session objects, and then appends the playlist and plays it. So that's one of the architectures that we came up with that allows you to be really flexible in this. So I could go into the indexer a little bit, but I also see that I'm fairly close to my questioning time. So I'm more than happy to answer some questions, to save some time for some questions about it, or show a short video of how this whole thing works. So maybe I'll go ahead with some questions. Yeah.
You said that Spotify is your delight, if I remember correctly.
Spotify is a
delight, or favorite application currently for playing media.
So we have not yet targeted Spotify directly as a plugin into this.
This is not a question. The question is, for example, as Spotify is mostly used as a media player. Did you contact with them regarding having this interconnection between your media manager possible and Spotify? Because Spotify actually covers the remote control you talked about, if you're aware about Spotify Connect, right?
Sure.
So the only missing thing is spreading different media for different passengers. And
right. Spotify's API would actually fit relatively well into the plugins. So we could theoretically implement a detection mechanism for Spotify. Now Spotify has different modes. You have a free mode and you have a paid mode for Spotify. So there are different things that you can do in both of these different modes, right? The player itself and the remote control, all of Spotify's API would fit very well into this mold, and we could write a wrapper that fits into this mold to get it working fairly quickly. So that I have looked at. Have I done it? No, I have not.
Okay, thank you. One further question, maybe? Sorry.
any thoughts on DRM plugins, digital rights management plugins, so that we can play protected contents?
DLNA?
DRM.
DRM, yeah. So DRM plugins, I think this is most DRM plugins or most plugins. So DRM is at a lower level. DRM typically is a term used at the lower level of the media reproduction. What people typically do is DLNA plugins, or as DLNA media playback for protected content that is either encrypted or protected otherwise. This system actually is, the media manager has been designed with the idea of using DLNA as DLNA players and DLNA plugins. There are, as far as I know, 2 open source solutions for DLNA. One is called Rigel, I believe, and there's another one that I'm familiar with, but I'm blanking on the name. But both of these, again, would fit extremely well into the whole idea. You write a plugin, you interface with the DLNA player functionality, with the DLNA term is renderer for that, and you can write a plugin that actually indexes the DLNA source, and that's almost the easy part of it. Of course. Correct. You can put proprietary players that implement DRM at the lower level as plugins into the system. And then you can have DRM, So for example, my default player in the system is a GStreamer based player or an MPEG 123 based player. However, automotive systems usually use a proprietary media player for media reproduction. If you have an interface that consists of play, pause, indexing, and so on, you can use that player. It's the exact same interface. They use the exact same interface, and you can just interchange them.
Okay, good. Thank you very much for your time.
Okay, thank you.
It's an appreciation of your time. Here's a
present
from our side. Enjoy.
Thank you very much.
Now we have a break, and after the break at 4:20, up next is Alistair Adams with a presentation about the QtWS Automotive Suite. Thank you very much.